Hello, YouTube. I'm Carrie with Alpenglow Industries. This is our Wednesday solder session, and we are putting together a pretty cool kit this week. It is called the Mystifier because it is mystifying. At least its original function was kind of mystifying, and we'll talk a little bit about that. But this is a super cool kit. It was put together. This is a replicator of an original Eicocraft kit that Brent Hauser put together, and I don't even know how I originally saw his Mystifier kit on Twitter, but it was cool. It like really caught my eye because it was like this neat retro kind of thing, and it uses neon bulbs, which is always cool. Can we go to the comments part? Yeah. Okay, cool. And yes, so it uses neon bulbs, so it has this like really cool little twinkling effect. And you know, it has that like nice warm light that you just don't get from LEDs. It's also kind of cool because the neon bulbs, which are, aw, hello, Sawarlinks. How's it going? Are you ready to be mystified? Whoa, I feel like I should have prepared a magic trick or something, but I'm not good at magic tricks, so. But these are, hey, Brent, I'm excited that you're here too. Thank you so much for making this kit and sending it. So these are the super cool neon bulbs that I was just talking about. And okay, so we have a different microscope set up this time, and I think it's a better camera. It's not our final camera, but it's a lot better than the soda straw view. So yes, bring on the mystery. Whoa! So yeah, these are those little cool neon lamps, and they're actually still sort of made. You can get like an updated version off of DigiKey for like only 33 cents each. So I thought it was kind of cool because you know, the other neon things that people are kind of used to seeing with retro kits are, of course, Nixie tubes. And Nixie tubes, I don't believe anybody is making them anymore. The Russians were for a while, but I think all you can find is old stock now. And they're pretty expensive because of that. So like they can cost, I think that they might cost upwards of like $15 to $20 a tube now. And, you know, there's a lot more going on in Nixie tubes. There's like individual numbers and stuff like that. So like, you know, legitimately they are more complicated. But these guys are, you know, they're cool. They're neon. They have that cool light, and they're like 33 cents each. So it's a little more accessible if, you know, you don't have the budget for, you know, a Nixie tube clock that costs like hundreds of dollars by the time, you know, you're done buying all the tubes. So yes. So the original kit, which Brent here, who is here with us on the chat today, very excited to have him here. Thank you so much for joining us. So he basically like wanted to replicate this original kit that was done by Eicocraft. And so the original kit was like, I haven't seen one in person. I've only gotten these assembly instructions, but I love like the old circuit board, you know, hand laid out traces and stuff. That must have looked really cool. And the original circuit is like kind of crazy. I'm going to see if I can zoom in on that a little bit and get you a better view of it. Let's see here. Yep. So yeah, so there are lamps, you know, they're basically being driven off of 90 volts. And there's this crazy RC network that like feeds to a bunch of other lamps. Like each lamp's, you know, this one side of each lamp like feeds through an RC to like 3 other lamps. And you just look at this and you're just like, what the heck is going on? What does it do? Well, the simple answer is it just randomly makes the lights twinkle. And so it's kind of like a cool old analog way of doing that. But I think it's kind of interesting because and I should let Brent maybe pipe up in the chat here. If you could tell us a little bit about your experiences first trying to replicate this particular circuit and kind of what happened, that would be cool. So I'll let him do some typing here, and I'll read out the responses for anybody who's joining us by audio and not really reading the comments. So. Oh, hello, Brad. Oh, cool. Brad says he's in a meeting, but has been looking forward to this live build for a while, so has it playing in the background. Excellent. Glad to have you here along. Yeah. So I'm going to go over, I think, to microscope view, y'all. Awesome. If we can get it in the microscope. So most of this kit is surface mount, and with pretty much the through-hole parts being the lamps themselves and the terminal block for power. So you can see that guy right there. And it's kind of cool. So I will fast forward a little bit here. So this one doesn't have the crazy RC circuit. It has a PIC microcontroller, and I thought it was kind of cool. It both, creates the pseudo-random blinking pattern, but it also controls the loop that creates the 100 volts that drives the tubes. So Brent didn't actually use an external chip, which is frankly what I would have done because I'm lazy. So, usually you can get voltage regulator chips that are like step-up converter chips, and will convert, your 5 volts in this case to, a variety of different voltages. And so what I would have done is I would have let somebody else do the hard part for me, and I would have just tried to find a chip that does like 100 volt step up conversion. And but Brent is cooler than that and is actually using the PIC to drive the voltage converter, and so he has it generating like the square wave that makes the inductor and capacitor circuit charge and discharge, and has the feedback going back into the PIC, so you can like run a loop on that. So yeah, so this is really like a very minimalist build, which I also kind of liked. Okay, so Brent says that the first version he made was over 20 years ago, and it was an exact duplicate of the original circuit, but with the new PCB layout. And it worked, but not as well as the original. Mystifying. Sorry, if you're, you might get sick of me saying mystified, but I'm going to do it all hour. So fair warning. So Brent, why did it not work as well as the original? What did it do differently? So while he's typing in an answer to that, I will start to go over and kind of like plan out assembling this guy. I think, definitely want to do the surface mount first and the through-hole lamps last, because the through-hole lamps will stick up off of the board a fair bit. And if we did those first, it would make it hard to put any of the surface mount components on. So through-hole stuff last. In terms of which components first or not, I'm not sure that it makes too much of a difference. I generally like to do smallest components first, more or less, and then like largest components last. All right. So Brent says, aha, it blinked, but always in a repetitious pattern, not in a random pattern. Mystifying. So yeah, I think that's super interesting. And I kind of wonder, like with these kind of oscillation circuits, so the circuit that I used on the I voted boards, which is like a little like, astable transistor oscillator circuit, it actually depends, like for the startup condition, it actually depends upon having like a slightly different RC circuit on either side. And so generally what that means is that you'll have like a slight difference just due to tolerances in the two resistors, let's say, or the two capacitors, either one, but like resistors tend to be pretty different. And so basically that little bit of an imbalance makes it so that like, one kind of, charges or discharges faster than the other, and it kind of like jump starts the circuit and makes it all start going. And so I kind of wonder if in this case, perhaps, Brent's Brent's new board had new components in it, and maybe they were too well matched. And so maybe because of that, there was just like a very repeatable pattern as to like which light kind of, got power first and started charging all of the little RC oscillators first. That's my theory. And I am debating, like trying to like play a little bit more and test that out, like with a different board but with the original RC circuit, because I think that would be kind of interesting to see if you could repeat the whole thing with just RC stuff. Okay, so how many pre-show beverages? No, like, I'm pretty good about like waiting until the show starts, because otherwise I really wouldn't make any sense. I have trouble enough making sense as it is. But yes, the beverage today is local brew, Central Coast Brewing, Monterey Street Pale Ale, 5.5 alcohol percentage, going with the theme of keeping it, kind of light on the alcohol percentage side, so that maybe I can make sense and talk and solder and stuff at the same time. We'll see. Okay. Cool. Brent thinks my theory is a good one. I like it. We'll test it out at some point. Okay, so let's solder some parts. I think I'm going to start with these little SOT23 guys first, because they're the tiniest. So little transistors are in a little bag, and taking them out here, little ESD bag. And so also, in case you're wondering, Brent has all of this stuff up on Hackaday. And he's like documented the whole project there and has like links to certain things and kind of the story of it. So you can go and totally check that out. All right. So peeling off a little bit of tape and getting going. Dumping out transistors on the desk. Hopefully I won't lose them. Choop. Oh, and so last week we had we tried to use a new soldering iron and sort of had a tip malfunction at the beginning. And this week, Robin just very lightly sanded the tip to get some of that oxidation off, and it seems to be working better. So we're going to try it out again right now. But if not, we always have the trusty Metcal backup, because that's still kind of my favorite iron. So let's see. You can kind of see that it's sticking a lot better to the tip. It's still not sticking to the very, very tip. It balls up right behind it. That's kind of normal. Generally the actual point of your tip is the coolest part. So solder will typically always ball up right past it. And that's also why you want to try to use the the sides of your soldering iron when you're doing surface mount soldering, not actually like putting the actual tip directly on things. You always want to use the side of the tip because it conducts more heat. So I am also going to be using some flux because flux makes the world go round. And let's see, we got this there. I might try something a little different this time just because it's nice to show kind of different things. I am going to use the lead-free flux. And you might be like, lead-free flux, isn't that kind of weird? Like, isn't all flux lead-free? Yes, flux itself is lead-free. It's kind of a weird name, but what it means is that it is flux that is specifically designed for lead-free solder, which means that it has a little bit of a higher like vaporization point. So it can stand up to the higher temps that lead-free solder uses a little bit better. And yeah, if you remember from last week, we used water-soluble flux, and water-soluble flux, it flows so nicely and it makes super shiny joints, even with lead-free solder. And, you know, this is not quite flowing quite as easily. And, you know, that's okay. That's okay. It's still flowing, but it's just not quite as nice as that water-soluble stuff. Alcohol and high voltage don't mix. Yeah. That was another plan. I don't want to be like really stupid and start touching the 100 volts and electrocute myself on YouTube live. That would kind of be embarrassing. Common tolerances. Okay, question. What are the common tolerances for SMD? Do they have the same range as through holes? Yes, they do. So for resistors, you know, 5% and 1% are super duper common. And you'll even, you know, the way that resistors are made, from my understanding, resistors are made and then they're tested and grouped by what they actually are. So it's not like there's a specific process for making 5% resistors and a specific process for making 1% resistors. It's like they make a bunch of resistors and they test them and then group them by what their tolerance actually is. So that said, like, resistor manufacturing is pretty darn consistent these days. So, you know, you might get a bunch of 1% resistors that are within 1% of their advertised value, but are all very, very similar to each other and almost identical. And then, yeah, you can get, boy, I don't know what the lowest tolerance resistor you can get, but you can also easily get like 0.1% resistors and I think like 0.05% resistors. You can maybe even get like 0.01% resistors. The DigiKey search would probably tell us that, because the DigiKey search is wonderful and has all of that stuff available parametrically at your fingertips. So in general, like for me, if I'm, you know, when I'm putting a resistor into a board, I will typically use 1% because there is so little difference in the price between 1% and 5%. It just, you know, a lot of times you just might as well use the 1%. But, you know, consumer electronics that are made by like the hundreds of thousands and millions, you know, suddenly like a, you know, 0.2% multiplied over how many resistors per design and, you know, millions of units, that actually starts to add up. So that's why people still do use the like the higher percentage tolerance resistors. So another thing that I'm noticing when I am soldering this, which is like totally normal and fine, but is always worth mentioning, especially for people new to surface mount soldering, is you could see like how I had sort of like a little bit of trouble per se with that pin. Like it wasn't flowing quite as nicely. I had to linger on it a little bit more. And what's going on there is that is the power pin. And so you can kind of see on this one that I haven't soldered yet that there is a plus. You can see sort of a plus sign kind of attachment to the pad. And what's going on is that it's attached to this big plane here. And the plus is just a little bit of a thermal relief. So instead of being directly connected to that whole big plane and your heat instantly, spreading out and conducting throughout that whole plane, the pad is like slightly isolated from that. So it stays hotter, like the heat stays a little bit more localized because there's just a smaller heat path, conduction path out of there. And that is specifically so that it is easier to flow that pad and to solder that pad. Without that, we would have a really, really hard time. But even so, it has like more thermal mass to that plane and stuff like that than, these other pads, which are just going to these skinny little traces and don't like have hardly any thermal mass at all. So those pads tend to be super easy to solder, whereas the power pads tend to be a little bit more difficult, just requiring a little bit more lingering. That's also why I typically like fatter tips, like screwdriver tips, or like kind of finer chisel tips, because they conduct heat so much better to the pads. Whereas like a very pointy tip, like the one I'm using now, it's not quite as good at that heat conduction, because the tip doesn't stay quite as hot. And so it's just like a little bit harder. But, I think that it's worth showing you these different things because, ultimately you're going to have, you're going to be doing stuff with different equipment, different irons. And, you might be wondering, oh, what's the problem here with this pad? Like, why isn't this flowing as well? And so you can also see that like I tend to use more solder on it. And that also helps too, because the solder will melt. The flux, mixes in with the solder, and the melted solder also acts as a better heat conductor between your tip and the pad. So a lot of times if you get like a nice ball of solder on your tip and use that to solder the pad, it's a little bit easier than just trying to use a tiny little bit of solder. Yeah. So it looks like we got like 3 more. Just flexing all of those at once. All right, ground plane, yep. So SMD resistors are made, then graded by how far each deviates from the target value. Yes, that is my understanding, at least. I would love to visit like a resistor making factory at some point in time. I think that would be rad. Relief tabs lessen the extra thermal mass. Yep, but do not completely eliminate it. Correct. Makes things a little bit easier, but still is a little bit harder to solder than sort of your normal signals. And I feel like that's something that's worth pointing out for beginners who are just learning too, because, sometimes they'll kind of get stuck on a pad, or they'll notice that like, oh, I was doing so well, and then all of a sudden, like, I couldn't solder this one pad or something. Like, is it me? Am I doing something wrong? And that can be a source of frustration. Whereas it's like, no, it is probably not you. It's actually probably the circuit board. Factory visit would make a great video. Yeah, right? I think we would probably have to do a bit of traveling to do that. Yeah, I don't think that there's really not much passive manufacturing in the US anymore. It's pretty much all done in Asia, all semiconductors, all electronics components, and like scattered all over Asia too. It kind of moves, kind of like textiles, actually. It moves to where the labor is cheapest. And then that industry, stays in a spot for a little while, builds up a skilled labor pool. Labor then starts to get more expensive, and then it moves somewhere else where labor is cheaper. So I kind of wish we could get out of that cycle, it's a bit exploitative. But it's also hard to convince people to pay more for things, right? When we're so used to cheap electronics. All right, let's see. Second to last one. And last one. Oh, and Brent even gave us an extra transistor. Thanks. Just in case I sent one flying. You never know. Yeah, these are little, this package is called a SOT23, SOT-23. There are also a million other names for it. If you would like to know them all, you can buy a handy Alpenglow Industries What the SOT transistor ruler. You like that? Yeah. Product placement. But yeah, it's a very common package for a lot of different things. And the nice thing about it is that, you know, it's hard to, you can't really put it in backwards because it only has 3 pins and the pattern is asymmetrical. So there's only one way that you can put it on the board. But the one interesting thing about SOT-23s, I haven't seen this in a while, but there's not necessarily consistency between manufacturers about which pin is numbered which way. So pretty much always this guy will be pin number 1, this like upper one that's in the upper left right now, right here. And I would say that most times I see this one here, the one right below it, as being numbered pin number 2. And then the one on the single one on the opposite side being numbered pin number 3. And that kind of goes with normal IC pin numbering, where you start in the upper left corner, you go down one side, then you skip over to the next side and up the other side. So you kind of like make this U shape with pin numbers. But one thing that you learn is just like, as soon as you think that there's consistency with patterns and footprints, you find out that there's not. And it's usually because you mess up a pattern on a board. And so some manufacturers will label this one as pin 1 and then skip over here to be pin 2 and then skip over there to be pin 3. And yeah, that's kind of annoying. So you always got to check your footprints and the data sheet and make sure that your assumptions and what the manufacturer is actually doing kind of line up. Cool. Oh, the microscope video is working well. Yes, thank you. We actually sort of have 2 microscopes going on. So we're not using the trinocular port this time on the microscope, on our actual new microscope here. We have a separate video, it's basically an inspection camera that's a monocular that's set up to the side and pointing down. So, and we just kind of like lined it up so that they were basically both pointing at the same thing. But yeah, the video is much better from that. But it's a little bit tricky to get the same field of view in both of them. And yeah, we're waiting. We got a new like official trinocular microscope camera, but there's like adapter issues. So next week we should have like the right camera with the right adapter in the trinocular port of the microscope. Field of view should be totally the same. Fingers crossed. We're getting there step by step. But yeah, it's like way better than the soda straw. The soda straw was super annoying of last week. So yeah. Okay. So now what should we do next? I think we should solder up. Let's do the 0.1 microfarad capacitor, which is right above the pick here. So it's like that guy. All right. So we got one little capacitor here. Yep, and we should probably flex it. Flex it. So yeah, I believe that this lead-free flux is also no clean, I believe. It's either no clean or rosin, but I believe it's no clean.
So does the flux, just the regular flux, have lead in it?
No,
so that's specifically for
it's
that
just
type of solder.
Specifically for the lead-free solder. I feel like it's labeled kind of weird. It like I would have been like flux dispensing pen for lead-free solder instead of being like lead-free flux dispensing pen. Yeah, it leads you to believe that there might be lead in flux, and there is not lead in flux. There we go. Yeah, it's not the best joint. I might actually, well, I'm going to do the other side first.
To be working fairly well, though.
Yeah, yeah. The tip is working pretty well. I would say it's like, I still like the bent Metcal better. I mean, I'm super.
Gonna say, tiny tips. Are just, they need to have a bend in them somewhere.
They're just, I feel like there are more options for how to angle your hand and how to angle the board. You can get more surface area. So I'm just like retouching this side, which is going to the ground plane here. I just put some extra flux on it and I'm refilling it so that it's like shinier and nicer. Yay. All right. And now we are going to do some resistors. These guys in here. That little extra transistor go over here. Cool. So now we have like a myriad of little transistors. We have 10K, 68K, and 390K. Awesome. So 10K we'll do first, which is...
2 of those.
Oh, we got 2 of those. Yeah, nice. Thank you for pointing that out. I will take 2 out then of the 3. Or maybe all 3. We'll see. Whatever happens, happens. Cool.
Close. Oh. It's spelled with a Y, but yes, it is Robin.
Nice.
I'm the voice behind the screen.
The disembodied, the mystifying voice. Woo! Mystifying. Oh, sorry. It's funny to me. I'm sorry if it's not funny to anybody else. Whatever. Mystifying. All right. So we got our 2 10K resistors. And you might be able to see better here. Yeah, I think you can. So last time I was saying that sometimes you have resistors that are marked on the top with their value, and these guys are marked on top with their value.
Oh, we can actually see it this time.
And I think, so I'll turn this around so that it's like the right side up. Let me solder this other side, and then I can kind of point it out a little bit better. I wish that there was like, the last time I looked for it, which was admittedly like a few years ago, I wish DigiKey had like a parametric option for whether or not a surface mount resistor had like markings on it. Because sometimes like you really want those, especially they're handy for kits, right? Where people might mix them up. Yeah, I mean, even if you have the tape marked, people might mix them up once they've taken them out of the tape. So, so for this one, it's labeled 1002. And how that translates into 10K, the last digit, 2, means that there are 2 more zeros. I know it's weird. It's, like times 10 to the 2, right? So so basically the value of this resistor is 10000 ohms, which is 10,000 ohms, which is 10 kilo ohms. Cool. So we will do the next one. And worth noting that like the general approach I take to hand soldering up a kit is what I'm doing here. Let me do it this way first. So I flux first. Do that again here. Flux first. And then I take like a small blob of solder on the tip and hold the component with my tweezers, just, just lightly down on the surface there. And then I just do a little bit of soldering right there. And since it's fluxed and since it's pre-fluxed, in general, that will result in a nice joint. In this one, it's not as great because I was talking for a while, and yeah, I'm pretty sure this is no clean flux because it doesn't stay wet for very long. It seems to evaporate kind of quickly, and I've noticed that with no clean flux in general, the working time is kind of short. So yeah, it makes a pretty nice joint. And I'm doing that on the side of the resistor that is not attached to the ground plane as well. So the side that is attached to the ground plane that I know is going to take like a little bit more heat and a little bit more solder, I do that second while I can have the solder in the solder in one hand and the tip in the other, and I don't have to worry about holding the component down while I'm doing all that. So now I'll do this. Cool. Let's see. Yes. I agree, Brent. So Brent says with the high voltage on this board, I might want to consider cleaning the flux residue. And that was also kind of a reason that I didn't want to use the water soluble flux for this board, because I feel like it's like maybe a little bit harder to clean with isopropyl. It's great to clean with water, but harder to clean with isopropyl, which is what we kind of have accessible right now here. And so, yeah, I wanted something that I could clean a little bit more, and that was like going to be a little less conductive in case there was any residue. But yes, we will do a very good job of cleaning this board before we put high voltage on it, because basically high voltage can sort of jump across impurities. It's a very different beast than like normal low voltage stuff that, probably people are more used to working with, like 3 volt, 5 volt, 12 volt. You don't really have to worry about that. 100 volts, you do have to start to worry about that, and you actually need like physical space between traces. All right. Let's see. So yes, the last digit marked on SMD resistors are kind of like the multiplier band on through-hole resistors. Yep, that is true. Now, it's not always the case though. Like are these 805s? Brent, or are they 603s? I have a hard time telling just like off the top of my head without having something handy to compare them, but I think that they're 805s. So 805s have more surface area available to write them out that way. 603s will sometimes have a code on them, but they're a weird 3-digit code that don't directly correspond to the actual value of the resistor. And it's a different code, and I forget how that works, but it's, alphanumeric, and you have to look it up and figure out what it is. 805s and 1206s. Okay, cool. Yeah, that's what I thought, but I wasn't entirely sure. I find for myself personally, 805s and 1206s are pretty nice to solder. And 603s are still fine, but they're about the smallest that I want to solder myself. I can do 402s. I used to be able to do 402s a little bit easier, when I was younger and had better eyes. But yeah, definitely I'm not interested in ever soldering 0201s myself. And 402s are difficult, and I will only hand solder those if I really, really have to, if the design really calls for that kind of space savings, which some do. Cool. Hello, Brad. Have I tried applying solder to one SMD pad first? Oh, and then holding the component in place and reheating that pad. Yes, I sometimes have done that, and I'll especially do that if it's say if I were actually going to solder the the power plane first, right? Any power pads first. So if it's a power pad or ground pad, and I knew that it was going to be a little bit more difficult to reflow, I would probably just add solder to it first, because then I could spend a lot of time dwelling on it and get that nice coat of solder on. And yeah, and then you can take with your part with the tweezers, flux it again, and then just reheat the pad while you're kind of pressing down gently with the tweezers. I don't know. I personally find that sometimes it can just be harder to get the part flat that way. So I have an easier time like picking up the part off of the table, because if I do that, then my tweezers can't go like past the part. And so as long as I like pick up a part off the table and then put it on a circuit board that doesn't have any solder below it, then I know that part is going to be flat and I can hold it there pretty flat. So that works for me, but that is, you know, doing the solder on the pad first, perfectly valid way of doing it. So yeah. Cool. All right, so we are on to, we have a 390K resistor and we have a 68K resistor. So I'm gonna look here. So these guys say 3903 on them. So 390 and then 3 zeros. So that's going to be the 390K resistor. And then the other one, any guesses? 6802. So 68000, 68K. We'll do the 390 first, since it's like right there. True. Sometimes it can be difficult to peel the tape off. Tweezers are sometimes helpful for this. I have better luck with my fingernails. And I don't have long fingernails. I keep them short because long fingernails annoy me and I climb a lot. So can't do that with long fingernails. But it's usually, I don't know, for some reason it's easier for me to like get that little piece of tape started with my fingernails rather than like with the tweezers, which sometimes they're just kind of slips off of the plastic a little bit. Of course, now I'm doing it a little bit different. I like placed the part on, and so this is kind of another way you can do it. You can just like gently press down on the part to kind of hold it flat. You don't want to press down too much because these are ceramic parts, and like if you're really strong arming it, you could actually crack them. But it just kind of like keeps it in place a little bit.
When I hold them down with the tweezers like that, they always go flying.
Flying?
I never hit them properly.
Quite right.
Yeah.
Yes. So it takes some practice to figure out like you definitely have to get it in the center of the component, because if you're off to one side, it'll kind of like fly off. And then it's like just the right kind of pressure, like too much, and it'll totally go flying.
I found just holding the tweezers or holding it with the tweezers just
was easier.
Yeah.
Yeah. Yep. And I'll go back and forth. I won't necessarily like stick to one particular way of doing things all the time. So yes. So it's interesting to note that Brent put vias inside of his pads. And that's generally not something you do. And I'll tell you why. Basically, the via inside of the pad like that will eat solder. And so if you're having your boards done out of house and you have paste put on your boards. So the way the boards are done when you're not hand soldering them, the way that they're automated is that you'll have a metal stencil for this board that has openings over each pad, and they basically squeegee solder paste onto it. And solder paste is just teeny tiny solder balls all held together with some gluey flux. And so these teeny tiny solder balls like fill up the entire pad, then the stencil's taken off, and then the components are placed on those pads, and then the whole thing is sent through a reflow oven. And so what can happen is especially with like really small parts, like if you say had a 402 and you had a hole underneath the 402 pad, that paste could basically be sucked into the hole. And so you might not get as good of a solder joint on that side of the component because your paste would be like filling up the hole instead. And then there's also, I think that there can be issues if you have like really high temperature applications, maybe with like different thermal expansions and things like that. But I don't know. I don't really do any applications that are that out of the ordinary. Brent said he's been known to use his finger to hold parts to keep them from flying. You must have really tiny fingers, Brent. I couldn't hold out a finger. I couldn't put a finger on like a 12/6 part.
It's just too close to the solder.
Yeah. How many burnt fingertips do you have? I mean, there are also a variety of tools that people use. There are like kind of these dentist pick sets, you know, that are all sorts of different shapes and sizes that people use to sometimes hold down surface mount components. It's not awesome to use the tip of the tweezers like I do, because if you press too hard, then you can actually damage the tip of the tweezers. And like tweezer tips are going to get damaged over time anyway. There's no avoiding it. And you'll probably notice when I'm soldering here that like they're not super perfectly lined up anymore. If I were doing 402s, I would need better tweezers for sure, because like even that small of a misalignment can really make a difference on that tiny of a part. But for the stuff that we're doing, it's okay. But you just want to like make sure if you are using the tips of the tweezers to hold down parts that it's like you're doing it very, very gently and not like and like bending your tweezers. Bent tweezers are sad tweezers. Brent says he should have said fingernail. I don't know if that makes it better. I still think I would melt some fingernails if I tried that. All right. So now I think we just have the big stuff left. We have a diode. We have a inductor, ceramic cap, tantalum capacitor, and like through-hole stuff. And what is the SOT 223 part? Is that a voltage? Or no, that's the is that the FET for the step-up converter? Yes, I think. Hey, you know what? I printed out your schematic. I could actually look at it, I think we have it here somewhere. Yes, there we go. Yes, that is what that part would be. Excellent. Cool. Sweet. Well, I think I'm just going to kind of start on this side of the board and just kind of make my way over to that side. So we shall start with the ceramic cap. Oh no, Brad had to actually contribute to his work meeting. Boo. Let's see, what have you missed? We've been soldering. Talking about tweezers, different methods of soldering. Yeah, not too much. Talking about holes in pads and why it's generally kind of frowned upon. Yeah. One other thing that I noticed, I'll show you this in a bit when we solder the pick down. Brent is most definitely a pick guy. We had a conversation over email about that versus Arduino compatibility. And it reminded me of my good friend Pete, who's also a pick guy. He's like, people talking about Arduinos. Picks are great too. And they are totally legitimately great. And like pre-Arduino, they were totally the most friendly way to go. Ooh, this is a big pad with a lot of heat, right? It's just like immediately sucked it all away. So that's okay though. So that pad is sufficiently tacked down that the component isn't going anywhere. So we're just gonna like, go to the other side for right now, leave that for later. I'm going to kind of flex that again to give us a little fresh coat. And yeah, this one is actually connected to the plane. So we might actually have to get a better tip for this. We'll see. We'll see how it goes. And, you know, that's okay. Sometimes you just, you know, the right tip for the right job is a good thing. Don't be afraid to, there we go. So once I was able to get more solder in there and get more of the surface area of the iron along there, then I could conduct enough heat and really get that to flow. So, you know, so you can do big things with small tips sometimes, as long as your soldering iron can pump out enough heat. That's another thing, is that I don't really recommend using a soldering iron like for yourself that's like under kind of like 85, 90 watts. Those are the irons that I like. You could definitely use like a 60 or 65 watt iron, but it'll make stuff like that way harder to solder, especially at like the lead-free temperatures. And that's another thing we could do too. We could even, like we're soldering at 780 F right now, we could bump that up to 800. So it's maybe a slight bit on the low side for lead-free solder, which you really want at least 750 F for lead-free. Oh. Well, maybe I can't. Can I? Oh, there we go. This is a new iron for me, so I am not super familiar with its controls. So, okay. Oh, hang on. Oh. Okay, there we go. So I want 8, enter, 100, enter. Okay, so now it's gonna go up to 800. Yeah, so we'll see how this side goes. So now we're coming back to the side, which was looking super ugly. There we go. Let's see. All right. Yes. So we're talking about the vias inside of pads, and Brent is acknowledging that yeah, the points about like the paste and stuff like that are all true, and that this board was designed for hand soldering only, which is totally legit. All right. Now we're going to put on the diode. And diodes are, of course, directional. So we want to make sure that it is pointing the correct way. And so we can tell there are a lot of different ways of, you know, marking patterns on circuit boards. And it's kind of up to each individual to pick what way they like best. Or maybe your company like uses a convention too. But we can tell that pretty much always you want to mark cathodes. Don't be the person who marks anodes. It's not a good idea. You will be ridiculed. And you usually mark that with a line. And so the line is closer to the pad that's the cathode. And so here we can see on the silk that the line is closer to this pad. So that's going to be our cathode. And that should line up to a line on the diode itself. Now, this one is a little bit hard to see because this diode doesn't have like white writing on top. It's like laser engraved. So it's just sort of a different texture than the rest of the black chip. So it's kind of like black on black a little bit. And I don't know how, it's going to be hard to see. I wonder if I can you hand me like that little light? I want to see if I can, get like a little bit more light on it to make it a little bit more visible. But
do you want the whole?
Yeah, the whole thing's fine. It's either dead or choosing to not come on. Yeah, it might have run out of batteries. Let's see. I might have another light that's like sort of handy here. Harbor Freight Special. Does that help at all? Yeah, a little bit maybe. So there's just a very fine line that's like scribed on the top of this essentially. And you just want to make sure that that line lines up with the line that is on your cathode marked pad. So it's like right here. Cool. And I'm going to move this a little bit so that I can flux the pads. And like this stuff I could totally solder, you know, without magnification if I wanted to, but magnification is so nice to have that like once you have it, it's hard to solder anything without it ever again. At least for me it is. I know it can take a little bit of getting used to soldering under the microscope, but really it just takes practice. And I'm going to reflex that one because it's looking like a little sad and crystally. So I'm going to reflex that, reflow that. That's looking better now. And the transistor. Oh, good. I'm glad you could see the line. It's hard to say because the video that I see is surrounded by other, you know, StreamYard stuff, and so it's smaller than what the video that you're seeing. So sometimes I'm not sure if it comes across well or not. Obviously, we need more monitors. We already have like 3 in this room, and yeah, the solution is definitely more monitors. Yeah. All the monitors. Cool. Yes. Brent says he's forever spoiled with soldering under a microscope. Me too. Me too. Like, don't take away my microscope. All right. So I think I'm going to solder this like middle one first. There we go. And then I'll go back and solder the big tab. That's soldered pretty well. Solder this guy. That's pretty good. See, I'm using the side of the iron, so I'm able to get like a lot of heat on those pads. So they're soldering all pretty nicely. Cool. All right. Now we got the inductor. That's interesting. I don't think I've seen this package like this before that has like this little notch out of it. So, oh, of course you can't quite see from that angle. Let me try to shift the angle. There we go, maybe. So there's actually like a little notch in that inductor. So lining it up with the notch on the silkscreen. Now, usually inductors don't really care which way they're going. Is there something special about this one, Brent? Is this one actually directional for some reason? All right. That's looking good. Now, this capacitor that we're going on to is directional. Some capacitors are electrolytics, and tantalum capacitors are both directional. So you want to make sure that you install them like you would a diode. Usually, pretty much always, the capacitor has the positive side marked. So we'll just line up, and this guy is like a lot easier to see. So there's that nice line on the capacitor, and we'll just line that up with the line on the board. Is it a 100 millihenry inductor or 1,000 millihenry inductor? Let's see. Our schematic says 100 microhenries. Yes. So the answer is neither. Unless you were intending the M to mean micro and not milli. But usually I would write that with a U.
I like how all different components and things are named after the people who claim them, but they all sound, you know, pretty regular, and then just Henry.
And then Henry.
Then you just have a Henry.
Then you just have Henry in there, yeah. Yeah. A lot of French names to begin with. Volts for Voltaire, right? I think, and amps for Ampere, and
then Henry.
And then Henry. It's shielded. Oh, interesting. In some applications, EMI considerations can dictate which inductor pins go to which circuit node. In this application, he ignored it. Yeah, that's interesting. Huh. Yeah, even like all of the shielded inductors that I've used in recent times is like they're not necessarily directional. So that's interesting. Learned something new. Brent's avatar's name is also Henry. Nice. Yes, microhenries are the more common unit of measuring inductance in. Correct. All right. Cool. I think we're on to through-hole stuff. So I think I actually might right now just clean off this side since it's kind of... Oh, wait, nope. We got the pick. Oh, can't forget the pick. Let's do that one, and then we'll clean the side off. Yeah. Yay. All right. And so ICs are also directional. And so, you know, they definitely have a pin 1 and that is pretty much always denoted by like a little dot. So it's like right up here in our, right up there. And that corresponds, different people like do different things with the silk screen. So Brent has put a little notch, a little U notch in his silk screen to denote the pin 1 side. That is very, very common way of doing it. And so we just line that up. And, you know, I kind of, the way I do this is I generally like kind of bump it around a little bit until it's pretty well centered like that. This one's actually big enough. You could totally like hold it down with your finger. And I'll still do the technique of like tacking down one pad and then going back to it later to reflow it. No, maybe it'll be that one. It's going to be the last one, but I had a ball of solder that was like a little bit higher up on the iron than ideal. So maybe we'll do this second one in right there. Cool. And so that just kind of holds it in place while we solder the rest of them. So one thing I notice here, so this is just like a little bit of feedback about circuit board design and via size and stuff like that. You might notice here that compared to the outer diameter of the via, the hole is pretty large. And there's a word for like basically the part of the via between the hole and the outside that's called an annular ring. And typically you want to size your vias so that you have 8 mils of an annular ring around the whole thing. And what that does is it leaves there, it allows there to be a little bit of wiggle room for the drill layer to not be like perfectly aligned with the copper, things like that. So so that you'll be assured of having like a fully plated via with like full copper on all sides. These it looks pretty small. I mean, it looks to me like maybe it's just a few mils, like maybe 3 mils in some places of an annular ring. And so if this were like a production board that you were making hundreds of and you were shipping in products and that would have irate customers if, you know, they didn't work, you would want to be more conservative on that. And you would want to use a smaller drill hole or a larger via. Of course, space is always at a premium at a circuit board, and you don't want to make the holes too small because circuit board houses will generally charge you extra fees for drilling really tiny holes. However, most circuit board houses don't have extra fees until you're like down to 10 mil holes, like below 10 mils. So if you keep your holes like 10 to 13 mils, you usually void fees, and then like 8 mil annular rings around. So like one of the via sizes that I use a lot, I think, is like I want to say it's like a 35 mil diameter on the pad of the via, and like a 12 or 13 mil hole. So it just makes sure that there's like a nice fat area that you're not accidentally going to like drill and kind of break through that ring, which, you know, might mean that your via doesn't carry as much current, and that could be important for like a power layout or something like that. So just like tips and tricks and like good practices and stuff. But sometimes board houses will also randomly change hole sizes on you sometimes, and that's annoying. So Brent says he's using default Oshpark design rules, and yeah, the ring looks much more reasonable on the layout software. Yeah, it's funny how that happens. You get so used on the layout software of looking at things like incredibly zoomed in and way more than life size that like sometimes you'll get a board back and you'll be like, oh my God, I thought that there was like a lot of space there, or I thought that was a really fat trace, and it's really, really not. So yeah, that happens to me too, where I just get like so used to what it looks like, you know, when it's 1,000 times bigger than life size. You can just go right down there. Ooh, I got 2 with that one. Sometimes you can like drag solder stuff, although these are kind of wide pitch to try to take like one ball of solder and sort of drag down the side. And then you like rely on surface tension to kind of like follow the solder and not make bridges. That's a way that you can do fine pitch stuff really quickly if you're like really good at it. There should be 20 mil holes and 40 mil pads, but they clearly didn't fab that way. Yeah, totally. I agree. I definitely agree. That would mean that you would have like 10 mils of an annular ring, and that was definitely not 10 mils of an annular ring. Yeah, like I said, sometimes board houses will like change drill sizes on you, and it is really annoying when that happens, especially if it's like for a through hole part that then the legs don't fit through. Super annoying. So I just went back over that first one that we soldered. I just added some flux, reflowed it, so it's a nice solder joint now. So yay. Okay, now we are going to clean this board. I got some isopropyl, got some Kim wipes. And yep, just scrubbing. It's not super exciting to look at, but that's okay. So what's everybody working on? Is anybody putting together like other interesting kits or working on cool projects? What's happening? Nobody's admitting to what they're working on. Maybe it's nothing. That's okay. I go through phases. We're working on cool stuff. Speaking of Oshpark stuff, do you want to
cool stuff?
Yeah. Do you want to talk, Robin, about your board?
My angry board?
Yeah, totally.
So I made the Happy Rain Cloud board, and then we used Oshpark After Dark, and I changed some stuff, and so now we have an angry rain cloud board that is going to come at some point.
Yes,
and I'm very excited about it.
Should be probably next week. If I would I would guess that we should get a shipping notice like late this week or early next week. Should be pretty soon, I think.
Cool.
Yeah. So Happy Rain Cloud is all smiles and blue skies, and Angry Rain Cloud is all adorable frowns and black after dark board.
I definitely need to get 2 of those so I can make a pair of earrings. So then I can either wear the happy, colorful ones or the darker, angry ones, depending on my mood.
I like it. Mood cloud.
Mood clouds, yes.
Mood cloud. Did we ever decide what color of LEDs we were going to put on those? Did we order
red?
them? Did we do red? We might have done
I think
red.
we did red.
Okay. Yeah.
And then maybe some like yellow flickering lights.
Oh, yeah. I think we might need to order some LEDs and play more with them. See what colors that we can get in the self-flashing. I know we can get red and blue. Brent says to please send him some angry rain clouds and you're experiencing a severe drought. Yes. Are you in California, Brent? I forget where you are. No, you're not in California. You're on the East Coast, right? Someplace.
We had rain 2 days ago.
We did. It confused the hell out of us. Like all of a sudden Robin was like, is it raining? And I like stopped and I was like, well, it sounds like rain, but it's July and we're in California. It can't possibly be raining. And it actually like rained a little bit for a couple of hours, like legit rain that stuck on the ground and made stuff wet. It's crazy.
It was nice.
Yeah, it was nice. Twin Cities, Minnesota. I generally think of Minnesota as a pretty like a place that gets like a fair bit of precipitation, at least snow in the winter and stuff like that. So, ooh, Brent is working on a DIY smart thermostat, but that's been going on for 6 months or more. Oh, that's cool. Nice. I've kind of been wanting to do a somewhat smart thermostat on my house, but I have like one of those really old analog millivolt systems, so I have to figure out like how to interface with that. It's been a while since I looked into it. Let's see. Swarlink says his garage in Arizona cooled off enough with some monsoon storms. Oh, so you built the MP3 alarm clock kit, the Cyber City Circuits kit. Yes, I still have that one. I haven't built that one up yet. Perhaps next week, maybe. I will definitely, I think, do that for an upcoming stream. All right. So I'm taking like a little bit of extra care with cleaning the schmutz off of this one, trying to get it pretty nice. All right. Saw just like a little kind of fleck of solder right there. I'm going to get rid of. Cool. All right. Oh, Swarlink says he got everything but the speaker soldered. You want to bodge in a connector so that you can choose, either speaker or a headphone jack. Ooh, alarm in headphones. Bold choice. Yes, everyone is experiencing crazy extreme heat things. It is a bummer. And like fire season's already bad here. And yeah, fortunately we haven't gotten like the smoke cloud of death yet, but
oh god,
yeah, it was brutal last year.
Mm-hmm.
I may have noticed the extra ground plane clearance around the high voltage traces. Yes, actually, in fact, that's good to point out. So you can see there's a good view where we can have like a compare and contrast, like right there is pretty good. So we have high voltage traces going to the lamps. And so there's a little bit, you can see like a larger dark area there. That dark area is where there's no copper. So there's space between the surrounding pour and the power trace. So there's a little bit more space there than there is down here, where it's just sort of a regular signal trace going into the processor. And yeah, that's to keep stuff from arcing. Yup. All right. So, boy, yeah, I think we're on to lamps and the terminal block. Is there a particular order I want to do that in? I don't think it really matters. Could do the terminal block first just to get it out of the way. And so this guy kind of snaps in, if I recall. It is directional. There are like, let's see if I can show this to you. There are these two little pegs that are in the that are on the terminal block that key into two little holes in the board. I'm not sure. So I drilled a hole in the enclosure. Ciao. Awesome. That's nice. So it's always helpful when a through-hole part kind of stays in and you don't have to hold it in while you're soldering it. All right. So these guys, solder, solder. Okay. And the lamps. Dun, 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 dun. Cool. Let's see. I haven't really thought through how I'm going to do these. So let's see. Do I want to hold them? I think what I'll do is I'll use, I think I will switch actually now from the microscope. Yeah, let's switch to the normal down cam. Uh-oh, see the mess I've made at the table. So yeah, I'm gonna switch to just soldering these with my eyeballs because they're not all that small and it'll be a little bit easier. Okay. So, all right. I'm going to just hold the edge of the board. I'm holding the lamp in right now because I don't want it to fall out. And I'm just going to, let's see, just make sure that no, nothing's real close to the edge there. So I'll just hold the board and the vise like that. And then I can just maybe bend these out just a little bit. I don't want to be too aggressive with them. And so that way they will hang like more or less down. They might be, you know, they might be slightly crooked when we solder them in, but like, that's okay. Cool. Haha. Yes, that is exactly what I'm going to do, Brent. I am going to use my cylindrical vise to hold it upside down in the air. Good thinking that. Yep. So we'll just solder these guys. There we go. It's going to be a little challenging to poke them through from the opposite side and not being able to see them. But we'll see if I can. Actually, we'll just do this. Cheat. Pick the vise up. There we go. And let's see. Just very gently bending them to the sides. I tend to not like to bend stuff too much on like lamps and stuff because I don't want any force to be like transmitted through to the actual component. So I'm pretty gentle about that. I don't like bend them as aggressively as I would resistors, let's say. Yeah, this is looking good. Cool. And then number 3. right. So I have not yet gotten back to the Nixie kit that started the whole thing. But I do intend to do that. That one is going to be, oh, thank you, a bunch of fiddly soldering with those sockets that hold in the Nixie tubes. I mean, the sockets are a good idea so that you can actually replace the tubes if they need replacing. But, you know, getting them all lined up, getting the tubes lined up in the sockets, it's going to be a thing. So going to be a fiddly thing. But I do intend upon doing that one of these days and showing it to you when I have a finished clock kit. I'm also interested in finding out if the processor that looks kind of melted is in fact melted, or if it is if it's working normally. It came to me melted. I did not melt it. That is my story, and I'm sticking to it. All right. Okay. Second to last one. And last one.
That looks really cool.
I'm excited. It's going to be awesome. And boop. Boop. Yay! Yay! Cool. Now we're going to snip all of our little leads off. And we'll do a little bit of cleaning on this side as well. I didn't add extra flux to these pads because they were through hole and I just didn't really need to. I knew that like they would get enough solder that, you know, the flux that's contained inside the solder would be enough. And I didn't want to, you know, the cleaner I can keep the high voltage stuff, the better. So that was not necessary. All right. I'm going to check this under the microscope just to make sure they all look good. And yeah, changing the focus for me doesn't really help you right now, but that's okay. This is going to be quick, so I don't think it's worth like changing it just to change it back. Yeah. So yeah, that's looking pretty good. I think I'm just going to do one more round of cleaning. Again, just being a little more fastidious on this guy. Trying to get as much residue off as I can. Probably like, oh yeah, do that. Oop. Don't bend you over, guy. Yeah, the board looks small in regular view, but huge under the microscope. I know it is It is funny how your perspective like changes so much. All right. That's better, I think. Yeah. Cool. All right. So yeah, here it is. Ooh. Are we ready? Oh, and they're all kind of like at different heights. That's awesome. I didn't really want it to be like perfect, so that's my story and I'm sticking to it. But there we go. Woohoo. This is gonna be cool. All right. So like the last little bit, so I pre-drilled a hole in the case for the cord to come out of. Let's see. I'm just wondering, like, if I want to power it up first outside of the box or in the box or check anything. We could power it up outside of the box first and double check, carefully double check our 100-volt line. It's probably not a bad idea. So I'm just kind of cleaning off the workspace here, making sure we have a lot of room and that nothing's gonna like fall on top of anything or short anything out or create surprises that are not welcome. All right. Cool EO. And I'm just looking at our schematic here. Cool. So yeah, we can check the voltage across C2, the 1 microfarad cap, which is that one. That's like a pretty good spot to do it, where there's lots of space, lots of room for your hands to be away from things and stuff like that. And we can check the 5 volts if we want to across this guy. So let's do it. So our link says outside first. Yeah. All right. So we have the last little bit of thing to install. So this is probably like a good thing to beep out as well, just to be doubly, triply sure.
Is that going to need to go through the hole before?
Yeah, we could thread it through before, just so we don't have to take it apart again. Oh, could you grab a super tiny flat blade screwdriver? Yes. Cool, thank you. So yeah, right now I'm just making sure that we know which one of these 2 wires here goes to ground and which one goes to 5 volts. So the power supply that I have, and it's always good to double check this, so I will grab that. Power supplies should always have written on them somewhere the polarity. So it should say, this is actually probably maybe better in microscope view. So maybe I will try to focus this if I can. Ooh, yeah, there we go. Cool. So inside is positive, outside is negative. That's generally the way things are, but not always. So it's always good. It's always good to double check and make sure that that is indeed the case. I have had instances where products have used something that is center negative. I'm looking at you, brother P-Touch label maker. Okay, so we know that the inside is positive, and so we need to figure out, like, I would assume that is the red wire here. We'll see if that assumption is correct. Because it might not be. Who knows? you know, red and white, it's not red and black. Even if they were red and black, I still would want to beep it out. All right, there we go. So red is inside, white is outside. So white is in fact ground, red is positive. And, you know, while we're here, we can just like make sure that there's nothing wrong with the cable and that those two sides are not touching, and they are not, and that is good. You know, we could also do that here. That would probably be kind of a good idea to beep out the 5 volts, because that's probably the most likely place where there could be like a short. So we can just do that. It will probably, oh, no, it didn't beep for a second. That's fine. Sometimes it does if you have capacitance in the line. The capacitor will be a brief short right before it charges. So that's kind of normal. So yeah, I think we're good there. And we could like go across here. Boop. We're good there. So yeah, none of our power is shorted, which is good. Yay. So now we'll put it back onto volt reading and we'll get going. All right. So Brent has marked this plus 5 volts and minus. So we're putting the red to the plus 5 volts. I think I'm just going to do it this way so that I don't have extra stuff here that I have to like navigate around. So I'm not going to thread it through the case first. I'm just going to keep it like this, because we can always pull it out and redo it. So screwing down the positive. Oh, I might have, yeah, it's kind of short, so it's hard to bend in there. There we go. Oh, this guy needs to be unscrewed a little bit first. Bye. Awesome. So there we are. Doot. All righty. I'm going to plug it in here first. So Brent has done like an interesting thing with the power where like when you pull power and then plug it back in again, it actually adjusts the blinking rate. So in order to ensure that we just get like one good power up to begin with, we're going to plug in the DC side first. And so that's connected. And now I will plug in the AC side. And I will do that in a way that's not reaching over too many things. All right, there we go. Ka-chunk. Woo! Woo! Check it out. It is mystifying. Mystifying. Woo, mystifying. That's awesome. Oh, I love the color of these. I mean, I guess it's showing up pretty well. So we're going to carefully probe our voltage here. And yes, we shall do it this way. We shall keep our fingers, you know, like not super close to the tips, but kind of far away. And make sure that our voltmeter is good. Yeah, 99.8 volts. 100 volts. Woo! Looking good. Nice job, Brent. I love it. All right, so I'm going to unplug this now. Boop. And now I'm going to install it in the case. So Brent did a really nice job designing it to fit into these little Hammond cases that have all of these handy slots so that you can just slide a circuit board right in. I drilled a hole and put a grommet in for the cable. I realized later that I should have located this hole like a little bit off to the side so that there's sort of room for the wire to come, more room for the wire to come out and stuff. So yeah, we'll see. I might end up relocating that if it seems like the wires are getting too squishy. I could put like, I can just drill a hole next to it and put like a hole plug in there. It's not, you know, super sexy, but that's okay. I thought I was being all cool by remembering to like actually put a grommet in there, right? And then I just didn't realize like how how close it all was. All right. So let's see. I think I'll give myself a little bit of space here. So threading it through the hole. And now going to put it back into here. There we go. Whoop. Come on. There we go. Now screwing these guys down. Choo. Choo. Awesome. All right. Now we'll see if this is actually going to fit or if I'm going to have to do something else. All right. Aligning it in the sides. Let's see. Come on, line up. And the stiffness of that is causing me like a little bit of an issue. Come on. Maybe if I do this side first. There we go. And now I'll just kind of like guide it in. There. Oh, yeah, interesting. It's definitely going to be squishy. I don't want it to be squishy. Yeah. Let's see what happens if I can like get these wires to bend up a little bit. I feel like it's not my favorite. Oh, that's wire's definitely squished. Come on, you little guy. I'm trying not to squish the wire between the circuit board and the grommet, and it's kind of bending in a direction that I don't want. So this is definitely where I should have probably should have waited to drill the hole until it was all assembled and I had like a better visualization of where everything was going. But I wanted to install it here live, so I wanted to have that done ahead of time. Let's see. Will that go in? Yeah, that'll work. It's not beautiful, but it'll totally work. Oh, I bent one of our little lamps over in the process. Hey, lamp dudes. Okay. So now they're all straight. That's like a little, let's see if I can show you what I'm talking about with the squishiness of the wires. I don't know if I can get a good angle on this here. But yeah, so you can kind of see there that like my little power wires are kind of squished. I could also cut them off a lot shorter and just have them kind of go straight out, like straight into the jacket and then straight out. That might be an idea. Or I could put like a yeah, I don't know. Anyway, that's not too bad. Not too bad for right now. So we will screw in the screws, which come with the enclosure. That's always nice. And I might need to grab another screwdriver. I kind of feel like I need another full screwdriver set in this room as well. Moment. Cool. So, oh, good chat about the ICSP, about reprogramming it. No, there are no parts shortages, and yay, yes, the pick was programmed already. Brent did that for me because I don't have pick programming stuff because I'm one of those Arduino people. But no, I do actually want to learn more about picks because it's good to have a variety of tools in your toolbox, you know? Different things for different stuff. Okay. Woohoo! There we go. Yay. So I'm going to plug it in again. I'm just going to do it on the 5-volt side this time, and I'm going to just try to, let's, there we go. I'm just going to try to do it super smooth without any scritching. Choo! Awesome. So, yes. So, yep, there are ICSP pads on the bottom of the board, and that is for reprogramming it if you want to reprogram it. Yes, the PCB is totally fully sealed within the box, so now we can't accidentally touch the 100-volt, lines, which is always good. And let's see, there we go. Yes. Awesome. People meeting each other. I love it. So yeah. So, okay. Now I'm going to put it, see if I can lay it down this way for effect. Let's see if I can prop it up a little bit so that you don't get glare. There we go. A pair of tweezers, maybe. Cool. Okay. So now if I unplug it and plug it back in within 15 seconds, then it should increase the blink rate. Is that correct? I think. So we'll try that out. I think that's what Brent had said. It's been long enough now. Oh, I'll have to cycle power just to get in the right mode. I got it. Okay. So it's right after you like. Yeah, it has sped up now. Totally. Yeah, cool. Okay, cool. So it's in that like speed searching mode for like a certain period of time after initial startup, and then it settles at whatever speed it's been told by the number of plugs and unplugs you've done. So let's see. So if let's try to like start it all over again. So now it should go slow, I think, maybe. And maybe I didn't wait long enough. 15 seconds. It's a long time when you're on camera. Here, maybe I'll take a nice swig of beer to congratulate myself for a job well done. And to you as well, Brent, job well done. It's a super fun little, I like twinkly lights, right? And they're really cool. They're like glass tubes, they're neon lights. You got a little bit of high voltage fun going on. Okay, that was probably 15 seconds, right? Oh, I think I scritched it. That's okay. Let's see if we can. Oh, yeah, that is definitely faster than it was before. How fast does it go? Does it go mystifyingly? Ooh, that is pretty fast. It goes mystifyingly fast. That's pretty cool. That's pretty cool. That's a really, it's an interesting way that you've done that to, to change the modes by disconnecting and reconnecting power. That's not something that I have come across before. And I think that's an interesting way of doing it without adding a button, and yeah, you have that big, 100 microfarad capacitor there, which keeps the pick alive, even though the power has been unplugged for long enough to have it monitor that. And then, so it knows when it knows to go into that mode. I'm assuming here, at least that's the way that would make sense to me. And yeah, so then when you power it back up again, there it is. Okay. So it remembers the speed you want set. Okay. Oh, it doesn't revert to slow speed. It cycles from slow to fast, then back again when you reach the end. Okay, cool. Nice. So you're storing the speed in non-volatile memory. That's cool. That's awesome. I love it. Oh, it's nothing to do with power retention. Okay, stored in flash. Cool. Yep, and there it goes back to slow. Is there a minimum amount of time that you have to have it unplugged in order for it to kind of like understand that it's been unplugged and adjust the speed? Yeah, reach the slow speed now. Yeah. Yes. So Solarlink says, would a toggle and the power line yield the same effect? I was thinking that too. In fact, I might have an inline power switch. Let me grab that. Although if it bounces, inline barrel switches. You know, gotta have a drawer for them, right? So let's see. Okay. Now we've got our switch plugged in. So is it okay? So is it then? So yeah, explain a little bit about how that about how the speed setting works. Is it just recording basically like every time it starts up, it records that it started up, and then you're just like kind of using a mod function to get a certain number of speed settings and then like flip back to the beginning? Or does it actually like do something in the short amount of time between like where you've unplugged it but it still has power? So our links did not know that inline switches existed for barrel jacks. Indeed they do. Yep, now it's pretty fast. Now it's even faster. That's cool. All right, Brent's going to try to explain how he's doing the speed thing. That is cool. I like it. I like it on the fast twinkles. Or maybe it'll just remain mystifying. You thought I was done, didn't you? It's good to like crack yourself up, you know. Okay. So as soon as you apply power, it selects the next higher speed. But if you let it run for 15 seconds or more, it will undo that so that it will always retain the speed that you prefer. Oh, interesting. So only if you remove power within 15 seconds will it adjust to the next speed. Got it. Got it. So if you leave it on for a while and then turn it off and turn it back on again, it won't really, there won't be a speed difference then. But then if you turn it off and on again within 15 seconds, then it'll readjust. Got it. Got it. Got it. Cool. Thank you for explaining that. Awesome. Well, cool. Thank you guys for joining, and thank you so much, Brent, for like making this kit. I think it's super cool. If anybody is watching this like after the fact and thinks that this would be a kit that they would be like interested in making, like let us know, because you know it's possible that like myself and Brent could collaborate on a respin that's maybe even all through holes to make it a little bit easier, you know, for beginners to solder, and yeah, and do something like that, because that might be kind of fun. It would depend upon like, you know, being able to still get a steady supply of these lamps. But you know, so far the more modern ones are available on DigiKey, so should be good, should be doable. We'll see. Cool. Awesome. Well, I think that's about it. Thanks again for coming. Thanks for watching. And yeah, if you're watching this after the fact, don't forget to subscribe to our amazing YouTube channel. Cool. Thank you. Thank you so much, Brent. This was super fun. I really love it. It's definitely going to have a home in our shop, like on a desk somewhere. We'll have to figure out where. Cool. Bye. Yes, I'm really sure.